Hey everyone. So, my name is Oliver. I'm a senior data scientist here at AWS, and I'm joined on stage by Parvas, who's a senior data scientist at Swisscom, and also Marcel, who's a senior software engineer at Swisscom. And we've been closely working together for the last few months, and we're proud to present how Swisscom efficiently fine-tunes and deploys LLMs with SageMaker. So the agenda for today is going to look the following way. First, we're going to introduce Swisscom, customer service, and contact centers, and as well how LLMs are used and going to be used. And then we're moving on to actually how do you choose the right LLM for your use case. So we look at different factors that are important for choosing your LLM, how you inject business data to your LLM, and then also what tools and services are available on AWS. Next, we're looking at how we then actually started our journey with SageMaker for fine-tuning and deploying LLMs. Then followed by the results and impact we reached, and closing with some key takeaways and next steps. So many of you probably know Swisscom here in the audience, but still it's worth an introduction. So it's a leading telecommunications and IT provider in Switzerland and Italy, and it has a strategic partnership with AWS since 2021. And now I'm happy to pass it over to Parvas, who's going to talk you through customer service and contact centers.
Thank you, Oliver. Hello, everyone, from my side as well. I'm really happy to be here today and share our journey with you. First of all, I would like to express my gratitude to the team that contributed with their dedication and expertise and make this achievement possible. So a shout out to Kai and in particular in Bilbao. Some of them are in the audience today with us. So now let's dive into the details of this presentation. The Swisscom hotline operates under the principle that service involves direct communication with the customer. Its availability is restricted, ensuring that quality interactions are uniquely tailored to each person. Customers today are mobile and very well connected, expecting us to provide them with fast and trustworthy assistance anytime, anywhere. Our vision and strategy for the future is called Stellar Bridge. With Stellar Bridge, our vision is to offer an intelligent approach to customer service and be proactive. By being proactive, we mean we anticipate customer needs, we focus on understanding issues before they become problems, and we offer solutions without waiting for the customer to initiate the contact with us. Whether at home, on the go, or 3 a.m. in the morning, the solutions are just a single interaction away from our customers. Stellar Bridge enhances the customer experience through innovative identity and access management, data, and agentic AI. By optimizing customer identification and authentication, we eliminate repetitive personal information entries, saving time for us and for our customers. By leveraging ID scans and customer profiles, we proactively address issues and anticipate contact reasons. Our AI bots and agents of the future are able to autonomously plan, reason, and resolve most cases, and connect customers to human agents when needed. All of this to ensure an excellent service for our customers. So, towards reaching that vision, this is what we do today at Swisscom. Today at Swisscom, we are transforming our customer service and boosting operational efficiency by leveraging the power of large language models. In the contact center, offering personalized, fast, and efficient service, while maintaining flexibility and accuracy across interactions. Our expectations for delivering LLM-driven dialogue emphasize on our ability to access securely critical information for enhanced personalization. This data includes customer conversation history, preferences, and commonly raised concerns, as well as incorporating data like service history, ticket status, and subscription details when necessary. By leveraging all of this information, our goal is to offer tailored dialogue that resolves customer issues with high accuracy. On top of that, we provide flexible solutions which include fast responses and after business hour services. So, our expectations for large language models to help us achieve that include several key aspects. First of all, customizability is key for us. This will allow us to tailor our models to excel with high accuracy at the specific task at hand. Ensuring consistent latency with a defined upper limit is very important for us so that we can maintain performance reliability. The third pillar that is very crucial for us is scalability. Our models must be capable of handling our volume of hundreds of requests per minute at peak times and during outages where our voice channel experiences significant workload. On top of all of this, we would like to have control over updates and owning our model lifecycle. This will help us decide when to switch to newer, more powerful model versions with enhanced parameters, and avoiding forced prompt adjustments due to model deprecations. Additionally, we can leverage any available open source models to gain flexibility to evolving needs and rapidly market trend changes. In this portion of the presentation, I would like to explore the high-level architecture of our voice channel with you. The process begins with the customer voice input, which is routed through our cloud-based contact center for transcription. Once it is transcribed, the data is sent to our dialogue engine, which is the orchestrator holding together the business logic and process descriptions. We delegate the task of predicting the next action in the dialogue engine to the LLM, while dialogue engine remains responsible for performing necessary API calls, injecting RAG responses, and accessing other data sources. All of this to ensure that we retrieve accurate information. Crafting all of this together, we will provide a precise answer back to the customer, which will be converted to speech using TTS. To get ready for fine-tuning our small LLM, we start with data generation. Our objective is to effectively infuse business logic into our small LLM. We achieve this by crafting synthetic prompt completion data pairs using a bigger LLM, a large LLM, as the teacher. We start with a data that resembles production data, but it is anonymized. This data is stored in S3, ensuring both security and accessibility. Laying this foundation, we move into the crucial phase of fine-tuning the model with this data. The challenge, however, lies in executing this most efficiently. At this point in time, I'd like to hand over to Oliver to explain you the details of the process. Oliver, take it away.
Thanks, Parvas. So how do we now, when we have the requirements ready, choose the right LLM? I think this is a question that many people have at moments in time. And it can feel like there's a sea of LLMs out there and you just don't know which ones to choose. And I already promised some gymnastics activities to some of you. So can we see a raise of hands who sometimes struggles to choose the right LLM for their use case? Yeah, we do see quite a few raised hands, right? So I think we also had the same. We knew our requirements now, but yeah, how do we actually then evaluate which model is the best for our use case? And we came up with 3 main categories. So the model itself, then the use case, and capabilities and skills in the team. So of course the model itself has some characteristics. So the number of parameters, for example, is a crucial factor. Bigger or more parameters means it's usually more capable, can kind of contain more knowledge as well, but also, for example, usually it impacts latency to some degree as well because smaller models are faster. Then also interesting, of course, is it fine-tunable or not? What does the commercial license look like? Is it a proprietary model or an open source model? And then also the data trained on, right? So if you think about if you try to offer a service in a specific language, but the model was not trained on that language, that obviously will be a challenge. So all of these things matter, and also how much input and output are you expecting the model to produce. So I think many of these factors just come together there towards the model characteristics. Then the use case itself, right? I think this is also neglected at some kind of points in time. So really think about how complex is your task. Is it like a relatively small set of document types that you're trying to classify to 0 or 1, like a binary classification task, for example? Or are you really inputting like multi-page documents with complex vocabulary and expect some complex outputs as well? Then usually you will need more capable LLMs for that. And also the load. So I think, if you have like inference once per day or once per week, then of course it doesn't make sense to have a persistent endpoint all the time. So I think this also shows you a bit which direction you can go here. And then lastly, this one is also important, kind of the capabilities and skills in the team. So if you have people that are able to fine-tune a model, then also maintain it and deploy it into production, I think then great, you have flexibility of choice what you want to go for. But if your team consists more of application architects, for example, that are less knowledgeable in fine-tuning and maintaining models in production, then maybe also an API-based solution might make more sense. Now that you have the right LLM, it still doesn't know about your specific business data, your business logic, and doesn't know how to help you in your business processes, right? So it's just a bare LLM, but it doesn't have your context. So typically there are some, we'd call it theoretical methods to inject some of the business data and logic into your LLMs. So for example, you can do continued pre-training where you just add more corpus of text, for example, in specific domains. So imagine in healthcare you have a very specific and complex vocabulary, and some smaller models just don't have that specific vocabulary. So you could pre-train with that vocabulary. Or also for telco, for example, is also a specific vocabulary. So you could then just do continued pre-training to make it more capable in those domains. Then probably many of you also know retrieval augmented generation. So here you have, you keep your model weights fixed, but then, for example, some knowledge and text that is coming from documents, you then kind of chunk it and do vectorize it via embeddings and store it in a vector storage. And then when a user query comes in, you basically, via a similarity search of the query versus your vector storage, you find the most relevant examples and enhance your context that way and answer the question, the original user query, with the knowledge from the documents, basically. Also agentic, as you can see with the recent releases that also AWS did, agentic is a very hot topic at the moment to inject some business data and also make kind of LLMs speak to each other, right? So this is also something that you can do also to kind of embed APIs and data sources and so on. So this is also a method that you could go for. Something that we already hinted on, fine-tuning. This is something that we did in the course of this project. So where you, for example, have prompt and completion pairs, and you basically teach the model in a supervised manner, just as you would in other traditional machine learning settings as well, how to behave when new queries come in. And then, as all of you probably also know, prompt engineering. So you can, for example, in the prompt itself, give instructions with few-shot learning. So you, for example, give 3-4 examples how an input and output should look like, and then you actually have the user query that comes in, and then, you can basically instruct the model to answer this way, or also more generally instruct the model how to answer incoming queries. And I think very important to mention is that you can do multiple of these things together, right? So you're not bound to just one kind of method. So we, for example, do prompt engineering, fine-tuning, and are also currently evaluating some RAG approaches. So now that we've looked at how to choose an LLM and what methods there are to inject the business data, what services does AWS actually offer to make this happen, right? So I think this is a very comprehensive slide. I don't want to explain all of the services, but you have the different layers. So on top, you have the application layer, where it's really more about building the use case rather than going deep into the models and so on. So I think this is really more for application builders. Then you have the AI and agent development layer, where you have services like Bedrock and Amazon Nova, like our own models and third-party models, and also some customization capabilities, and also the recently released Agent Core. And then if we go one level deeper at the bottom, with Amazon SageMaker AI and the AI compute, you really go a level deeper, get more flexibility, and just overall can also control the code and the models and the life cycle in more detail. So as you can see, SageMaker AI offers exactly what we're looking for. We want to do model training, fine-tuning. We want to manage the life cycle. We want to do MLOps and also deploy. And therefore, in the next section, we want to talk you through the journey we took with SageMaker to actually go from experimentation over repeatable model building pipelines towards deployment and operations in production, which Marcel is also then going to speak about later. So as you can see here, we started with model experimentation. So we stored the data in S3, as already explained by Parvas, right? And there are also some pre-built images on ECR. So we didn't have to tediously build like Docker images, test if it works, and then redo the builds and so on for the Docker images, but really could just use the pre-built images to quickly prototype here. And in Jupyter Notebooks, basically loaded the data, took some open source models, and evaluated how well they perform from an accuracy perspective. We also stored those models, and then we were not only interested in how well they perform from an accuracy point of view, but also how well do they actually perform during inference, right? So things like latency, how many concurrent requests can we handle while preserving a specific threshold of latency. So I think those were also really things that were important to us during this period. And a few highlights here, because we're also speaking about efficiency, right? So we did low-rank adaptation. So instead of full fine-tuning, we actually just ingested a small portion of weights. So you can imagine like you add 1% of the original weights to the model itself and keep the original model weights kind of fixed. And therefore, you kind of get a lot of efficiency gains in training time of the model and the compute that you need to use for it. And research has shown also that still, via this method, you come very close to full fine-tuning with accuracy performance in that sense. As mentioned also, we did supervised fine-tuning, so we had like the prompt completion pairs and trained this way. And something that also helped us a lot is kind of the flexibility of instance choice. So experimenting, we could see, can we maybe take bigger instances to speed up training, but also maybe taking smaller instances because we didn't really need all of the compute for the really large instances, so that we also can save a bit on the price performance. So I think we really hit the sweet spot here for us. And we were able, during the experimentation phase, to get latencies around 400 milliseconds. Marcel is going to share later how it looks now in production. But this gave us good indicators that we're going to hit our latency targets as well in this very kind of latency critical application in the contact center. And we were also able to achieve very high accuracies, which kind of satisfied our requirements. And as mentioned before, price performance was also something that we looked at and was something that we were able to achieve with SageMaker. So unfortunately, Jupyter Notebooks are not really production ready, right? So we have to go through a process of actually building repeatable model building pipelines that have code versioning, and therefore we used SageMaker pipelines for that. So again, the data was stored in S3, and then we also used kind of the pre-built images again from ECR, and then we used SageMaker pipelines to orchestrate basically the training job, the evaluation job, and also the storing kind of the models itself to SageMaker model registry. And a few highlights here, what we were able to gain from this is that it's consistent and repeatable. So we can easily kind of configure the pipelines. We have a config file where we then just can point to a new data set, for example. So imagine we want to make specific new flows available, or maybe also Swisscom releases a new product, and this information of the product somehow should also be embedded in the dialogue engine that Parvas shared before. And therefore, we need to retrain regularly as well, and this needs to be done easily with config files too. If we then look at the lineage, with each run we want to know about kind of where does the data come from. So if we change the data, we want to know where did the model version actually get the data from for the training. So you have the full lineage from data to training, evaluation, and then the different model versions. And the model versions allow us also to compare kind of how the accuracy changes over time and which model version has which performance metric. Lastly, this allows us to manage the model lifecycle efficiently, and as you heard before from Parvas as well, this is something that was crucial in the requirements phase. And now I'm happy to hand it over to Marcel, who's going to walk you through how we actually deployed after model building.
Thanks a lot, Oliver. For the deployment, we had two main goals. First, we needed to validate the performance against the real application. And then second, we also wanted to have an easy, reproducible deployment process. If we look at the configuration of SageMaker, we have two main configs in our case. We have the model config, which has settings like where to find the inference image, where to find the model, and also where to, like what model parameters to apply. The endpoint config, on the other hand, has more base infrastructure related settings, like what instance types you want to use, how many instances you want to use, the networking, in which VPC, which subnets will it sit, and also the scaling options. And you see there's quite a lot. Having said in the beginning, we want to have a simple deployment process. You don't want to apply that manually via ClickOps. So what we ended up using is the AWS Cloud Development Kit. It basically allows you to represent your configuration or like your infrastructure as code. In our case, we use Python because it was just a skill we had in the team, but you can take also any other language. So you basically define your infrastructure as objects. You can test them as you're used to. And then CDK basically takes care of synthesizing them into large YAML files, so-called CloudFormation templates. These templates are then understood by CloudFormation itself, and you can deploy it to CloudFormation, and CloudFormation takes then care of provisioning those so-called stacks. So now we had that model up and running, or like the endpoint up and running, and we had to validate the performance. Already in the beginning, the first results were quite promising. we added then step by step more traffic to this model. Currently in production, we have like 50% traffic there of all our requests in CIVR. And more importantly, we serve them with a median latency of below 250 milliseconds. That's super crucial to our use case. Imagine you're on the phone, calling the hotline, and you have to wait 10 seconds. You don't want to wait that long. So here, the latency is really less forgiving for that use case. Looking at the whole picture now, we see the model deployment and the model building pipeline. And the artifact, of course, is the model. So we build the model, then we ship it to the development pipeline, where we put it from develop until production. In between those steps, we apply some functional testing, load testing, and as well sometimes some manual testing still. Once we're happy, we ship it and continue to observe the metrics. All that, you see the model building, so the MLOps pipeline, as well as the application pipeline, it's all on Git. So it's all versioned, and you know exactly what happened. Looking at our current deployment and model, I think we built a solid foundation. We have monitoring. You get that with CloudWatch out of the box. You have metrics there. You can visualize them. But you can also export them, of course, to your internal monitoring system and add alerts. Then we apply security best practices. We use IAM. Since our application is running in EKS, we use pod identity. We do own the lifecycle management, which is really crucial to our use case. And then, as well, we can scale. Of course, there are room for improvement. Like currently, we have 2 instances up and running all the time. We have, I forgot to mention before, we have actually G6E family instance types running, and the fine-tuned model uses up. We use the base model is Llama 3.1 with 8 billion parameters, and we use around 90% of our GPU memory with that. So back to the scaling, it's a fixed 2 instance right now, and of course you want to have that in the future a bit more dynamic. Other things we can think of is using lower adapters, what you can use in SageMaker as well. But I think starting simple and adding complexity is was key for us, and I think makes also sense. And with that, I'll hand over back to Parvas for the results and impact.
Fantastic. Thanks, Marcel. So, I'm very happy to share with you the transformative outcome and impact of this journey. With our small fine-tuned model on a Llama 318B Instruct, we deliver accuracy comparable to the big LLM that we use as the teacher, while keeping latency in check with a guaranteed upper limit. To help us handle our hundreds of requests per minute at peak time load, our SageMaker deployment offers a cost-efficient solution, charging us hourly instead of per token or per request, so charging for the infra instead of service. And as well, mitigating the disruptions caused by model deprecation, mitigating the risk because of the disruptions that are caused by LLM providers that we have to do forced prompt adjustments due to model deprecations. On top of this comes the flexibility to switch instance type, change model type, and scale to handle unexpected traffic peaks. We recently launched our first production deployment, as Marcel said, marking the beginning of our journey to mature our process further. Through continuous learning, our goal is to address unforeseen behaviors in production and feed them back into the loop to generate new and fresh training data, ensuring that we maintain high accuracy across different use cases. With that, I hand over to Oliver to share the takeaways with you.
Thank you so much, Parvas. So going back from the start, what did we actually discuss today, right? So we introduced Swisscom, customer service and contact centers, and the requirements that the use case had. Then we looked into what were actually the factors that are important for us to choose the LLMs, so as kind of the model characteristics, the use case itself, and also the skills and capabilities. Then kind of how do we inject the business data with the methods like RAG, fine-tuning, prompt engineering, and so on. So this was also kind of key. And then we moved on kind of to the AWS AI stack, so the available AWS services at hand. Then kind of we went on the journey with you that we also underwent, right? So we then did model experimentation, consistent model building pipelines, model deployment, and kind of then how we run in production and do the operations as shared by Marcel. And then we looked at the results and impact we were able to reach through this project. So I think, some of the key takeaways that I want to mention here. So it might be a low-hanging fruit, maybe all of the 3 points for some of you, but I think it's really still crucial to mention them. So really define your requirements and the scope of your LLM beforehand. I think there has been for a long time the tendency to just stick with the frontier models as they perform best on some public benchmarks. But that doesn't mean they're best suited for your specific use case, right? So in our case, a smaller model with 8 billion parameters was the right fit because we got kind of price performance, latency, and so on that we were looking for, and still high accuracy performance. Then integrate your business data. I think for individual productivity gains, it's great if you use kind of the frontier models, right? But in order to assist business workflows and kind of automate some tedious tasks for you as well, it's really crucial to integrate your business data with the methods that we discussed and also through services available on AWS. I think many of you heard already about Agent Core and all these other services that are around to also make that happen. And then, of course, as you saw in our journey, at some point you have to kind of stick to the technology stack and the LLM that you choose. You cannot switch every week like, oh, I have a new great LLM here that I read about. So at some point you have to stick to your choice and then build it out, right? And that's what we've done for the past couple of months together. But then also be open to reevaluate your choice once you're kind of in a production state and somewhat stable, right? Because there might be new releases that solve your business problem at hand with more efficiencies even. So be open to reevaluate your approach there. Some actionable next steps. So if everything that we spoke about today was nonsense and you didn't get anything, then I think the Get Started with Gen AI QR code might be for you. So I think there you have some kind of recap of the services that we briefly touched today, some customer success stories, and then you can click through and get more knowledge step by step. And then if you're already on your Gen AI journey, but maybe need a sparring partner and want a second pair of eyes to move your project over the next stage, then also feel free to connect to one of our specialists. And also, if you want to, we're here for a couple of minutes after the presentation as well, so you can also come around or speak with any colleagues in the booth about it too. So with that, I want to thank you for attending our session. And also, since it's one of the last sessions, right, I want to thank you also for attending AWS Summit here in Zurich. Please feel free to connect on LinkedIn as well. Also please rate our session. We would be very happy to get your feedback. And with that, I wish you a wonderful evening. Schönen Abend miteinander. Ciao zusammen.